about bones. As I said you before, so it's one of the toughest lectures. It's a second tough lecture after the blood formation, as I think. So that's why all your attention should be concentrated here. So make some notes. And PPT of this lecture is already shared to you, so you can follow this if you want. And a record of this lecture will be present on YouTube. So that way, in any time when you're free, so when you're ready, you can read it, watch it again, and read the information from the notes. Also, you have books, so that's because in lecture we are unable to explain everything. So, but at least the basic conception is shared to you. So. I use your books, you have book Hussein Siddiqui, yeah, Altaf Hussein Siddiqui. So then use this book too for preparation. So because it will be necessary for you in final exams like PMC exam. Okay, let's start. So bombs. So
PMC is not accepting us.
who?
PMC.
What accepting you then?
Nothing, sir.
Okay, let's leave it. Yeah, I guess. Uh, okay, take a look. So here we have a bone. This is a structure of bone. So you remember it from anatomy, but let's follow some more conceptions. So let's follow more conceptions about it. Bone provides structural support, given shape and form to the body. So you remember, and that's why it's called skeleton. And actually, by analogy to skeleton, we name, for example, cytoskeleton is named also because of function of cytoskeleton to keep the shape of the cell. Yeah, so that's why skeleton bones, they main function provide structural support, given shape and form to the body. Also, by connection of these bones to muscles, so they provide the movement of our body, and by possession of articulation. Yes, so you remember we have joints, which are joints of bones. So on the surface of bones, we have joints, and through the motion of one bone to another, so it causing the activities of joint activity. We discussed in anatomy class in previous semester. So, another function which usually they are not discussed in anatomy, it's that bones are source as a stored source for calcium and phosphate. So we discussed a little bit that bones are predominantly in half composed of organic compounds, in half composed of inorganic compounds. So we'll discuss this in details a little later. But half inorganic compounds are predominantly composed of calcium phosphate. So different, it's known as hydroxyapatite. So this chemical structure, so inorganic chemical structure, which is present there. So how it is established, we'll discuss a little later. Also, one conception we discussed a little bit, that inside the bone we have a bone marrow. So bone marrow, we have two types of bone marrow, red bone marrow and yellow bone marrow. So in epiphysis and metaphysis, of these bones, we have the cellular structure. Yeah, so inside we have a lot of
Sir, share your.
departments.
Excuse me, sir.
Yes.
Sir, share your screen, sir.
Don't I? I'm sharing this, guys.
Sir, no, sir. I can't see
We
anything.
can see it.
Sir, it is visible to us.
It's visible, yeah. So Rashid, might be it's your problem. So to find this. Okay. I'll share it again. I'll share it again, then everyone can see it. So 1 minute. Okay, now it's visible, yeah, for everyone.
No, sir.
No. So let's.
No, sir. Yes, sir.
Yes, sir, we can.
We can.
We can.
Yes, sir, we can see.
Okay, so now let's continue. So in the so in epiphysis and metaphysis, so here we see the red bone marrow. So that's why I write it with red color. Yeah. So here in cells between this trabecula, so we will discuss the trabecular structure of the bone. So inside is collected blood forming cells. And blood forming cells all we discussed in blood formation topic. So all those cells are present here and facilitate their function in formation of RBCs predominantly, and also different WBCs, including the lymphopoiesis and myelopoiesis. Yeah. You remember myeloblasts and all these monocytes and granulocytes are produced here predominantly, so only here, but lymphopoiesis is here in a not abundant way, so because predominantly lymphocyte formation now in adult body is happening in some other organs like lymphoid organs. There are lymph nodes, lymph nodules, that what we discuss in next semester. Okay. So that's that I said about bone marrow. Also, usually is this bone long bones are subdivided into epiphysis. So here and here, so proximal and distal epiphysis, a diaphysis, and a short connection between diaphysis and epiphysis. It is known as metaphysis. It has no defined borders, but it is so it's clinically important because when we explain the location of fractures of bones, so we can say that it's diaphysis or metaphysis or epiphysis of the bone. Okay, but it's a point of another subject discussion. So let's talk about histological preparation of bone. So histologically, bones are prepared in two main ways. It's a ground bone preparation and decalcified bone preparation. Ground bone preparation. So when we just get the native bone, make a very teeny tiny narrow slide of this. So make it so narrow that light can pass through it, and we can see this structure. So we can see this mineral structure. So that's, you remember, bones are very tough, bones are very solid, and that's why it's made by predominantly this rigidness of the bone is made by calcium phosphate, calcium hydroxyapatite. Yeah, as I said it in beginning. And we can see all the structures. So structural changes in the bone are visible by ground bone preparation. Ground bone preparation. But if we want to observe cells, and structure of extracellular matrix in details, we need to use another feature. It's a decalcified bone preparation. Decalcified bone preparation is when we just remove all the calcium out of bone with help of acids. So for usually we use hydrochloric acid solution, so by which we remove all the calcium phosphate. So you see, it's lamella and inorganic matrix is difficult to distinguish. What is lamella? What is inorganic? What is lamella? We'll discuss a little later. But extracellular matrix is named as lamella. But here, predominantly, we need to observe. We can observe cells first of all, which are visible here. So we need to zoom it to understand it. But main idea you captured. Yeah, we have ground bone preparation and decalcified bone preparation. And here in decalcified bone preparation, we can use stains. So in ground bone preparation, using of stains is how to say, is senseless because here nothing can be stained because of calcium depositions here. Okay, a gross appearance of bone. So it's macroscopically we divide it into the compact bone and spongy bone, or also known as cancellous bone. So compact bone is usually present on surfaces in diaphysis. So let's show it here. So this might be explained as compact bone, this part. Yeah. So you see when connective tissue, so when matrix between cells is very compactly arranged here, and it has no gaps inside. And for example, in epiphysis, so let's me remove it. But so But here in epiphysis, you see that its cancellous bond is present here, so with a lot of cells, yeah, inside, and that's typical for cancellous bond, or also known as loose bond, yeah, or spongy bond. Okay, this is structure. This diagram which you observe right now, it's one of the toughest structure which you can understand. So you see, so first of all, it's a large bone, how it looks like, and inside the bone we have blood vessels. So that's a main difference between cartilages and bones. It possesses blood vessels. Bones are present with blood, and it's usually bummer for students that if you injure the bones, it leads to hemorrhage. Cartilages are not followed with hemorrhagia, but so stop presenting your screen, please, because you presented. So now I'll repeat this screen showing. Guys, that's why I ask you, don't late. So because when you late, so you start to present your screen sometimes. It's by mistake. I understand it's by mistake. It's not to damage you, not to give me damage, but still you can't observe it properly. So 1 minute. Okay, here you see this all the structures which we can observe here. So this entire bone. Again late. That's why I ask you never late. So it interrupts me. It interrupts the screen. It interrupts everyone. Okay, you can see that's a compact bone which is present here. So, and spongy bone is also usually present in a innate side of the bone, and inside the bone we have a gap, so they can form the medullary cavity. And this medullary cavity usually present bone marrow, and in adulthood it's usually yellow bone marrow present in this medullary cavity. But red bone marrow remains only here, only here. So in epiphysis and metaphysis of the bones. But still, here if you watch closer, so you see this is compact bone. This is compact bone, and it possesses osteons. These osteons, which are round in structure, and formation of them we'll discuss today too. And inside each osteon we possess artery, vein, and nerve, and also lymph capillary. So they are present here. Okay, between these osteons, so we can see the interstitial lamella, but above this we have the circumferential lamella. So we have circumferential lamella. So outside the bone, and circumferential lamella inside the bone. It's known as external and internal circumferential lamella. So how are they formed? Or also it's a point of discussion. So, but your point, what you need to remember, that bones are predominantly composed of osteons. So 1 minute. Predominantly composed of osteons. And some remnants of other lamella, so like circumferential lamella and external circumferential lamella and internal circumferential lamella. Okay. Okay, let's continue. And inside we have a specific structure. So inside every osteon we have central canal. So and you see once again in central canal are present one vein and one artery, and one vein and one artery, and one nerve, yeah, and also capillaries, so lymphatic capillaries are present. So let's discuss the structure of architecture of the bone. So once again, diaphysis, epiphysis, metaphysis, so epiphysis, diaphysis, and metaphysis are explained. But we didn't discuss the epiphyseal plate. So actually, so 1 minute. So epiphyseal plate. So you remember that bone is composed. So bone is primarily in embryonic period. It is formed from cartilages. So in cartilages, which are usually hyaline cartilages. And I said, yeah, so remnants of fetal skeleton, they are hyaline cartilages. But don't forget that actually actual bones are they are based on cartilages, and remnants of these cartilages are present in epiphyseal plate. You remember that bone is solid structure. It cannot grow in length. When it's fully calcified, when it's fully formed the mature bone. But in children, so we have remnants of hyaline cartilages. They are present in border between epiphysis and metaphysis, and this is known as epiphyseal plate. Epiphyseal plate is a remnant of cartilage which still allows the growth of bone in length. And when this epiphyseal plate is grown with the calcium and is replaced by bones, so then growth of bones is stopped. Then and this is and you can remember it from your history, yeah. So when you stopped your growth, when it was your last time when you get your high, yeah. So it happens in a period. So usually it's from 16 to 21 years. And so it totally stops. And you can be sure. So if your epiphyseal plates are replaced by bones, so your growth is stopped and you cannot continue growth. Okay. Usually remains the epiphyseal line is just remained like a bone structure. So which has no function, but it's just remnant of cartilage which was here. Okay, the bone marrow. So as we discussed, is red bone marrow and yellow marrow. And don't forget, we have other remnant of cartilages which is still present with us all our time. It is articular cartilage, which is also hyaline cartilage. As we discussed in previous lectures, this cartilage is hyaline and present without perichondrium. And that's why this cartilage cannot grow, cannot replace themselves, and a healing of this cartilage is very poor. And that's why so save your cartilages, save your joints, because to increase load to these cartilages can cause the very debilitating disease which is known as osteoarthritis. And actually a lot of diseases are related to this, and one of the most common is osteoarthritis. When this cartilage under the stress start to change themselves into the bone structure. And just imagine in your joints when bone is shifting along another bone, so of course it creates a pain sensation. So that's why these cartilages are very important to save them. Okay, and now let's talk about structure of osteon, and let's talk about cells. In lecture we have a scientific explanation of what is osteoblast, what is osteoclast, what is osteocyte, but my main idea to explain the function of these cells. So, structure of osteon is composed of cells, and which cells are mostly we have to discuss. There are osteoblasts. So osteoblast is a main productive cell of the bone. Osteoblasts are producing extracellular matrix. They are producing collagen type 1, ground substance, and also osteoblasts are responsible for deposition of calcium phosphate into this extracellular matrix. So you see, osteoblasts, they are not main cells. So it's don't forget that bone is a connective tissue, and the main characteristic feature of connective tissue is possession of extracellular matrix. And extracellular matrix here is almost similar as in dense connective tissue. So it also possesses the collagen type 1, also possesses the ground substance, but this ground substance is specific, unlike the unlike the connective tissue proper. So it's this ground substance is available for calcium deposition, and osteoblasts are also helping in this deposition. How it helps, we'll discuss a little later. Then when osteoblasts are produced extracellular matrix, so already produced, they envelop itself with extracellular matrix, and they are present in their own prison, as we discussed it in cartilages. Yeah, then cell is enveloping itself with and here it's a rigid prison. Yeah, rigid space, and space here it is known as so same as in cartilage. It named as so. Okay, it present in lacuna. Yeah, so here we have lacuna. So this lacuna is space which where cell used to be present here, and so 1 minute. Yeah, where cell used to be present, and this space was which was occupied by osteoblast, and cell shrinks and forms the osteocyte. Yeah, so you see, it's osteoblast is like active cell which is producing extracellular matrix, but inside, but when it envelops itself, became shrinked, and due to the shrinkage, so space is remained outside, and cell and this shrink cell is named as osteocyte. So, analogous to the cartilages. Here, remember, chondroblasts are present on upper side, and then when they envelop itself with the extracellular matrix, it forms the, or it makes the chondrocyte. Yeah, chondroblast makes the chondrocyte. Okay, that's main idea you should know. So that's similar to cartilages. But what is dissimilar to this? Of course, it's possession of osteoclasts. Some of you, so most attentive students of you, so you remember that when we talked about the blood, we said that monocytes of the blood, they are able to change their appearance, and they are part of mononuclear phagocytic system of the body. And one of the cells of mononuclear phagocytic system is osteoclasts which are present in bones, and osteoclasts are present here. So, and function is same as everywhere, so same as all monocytes. It's phagocytosis. But unlike others, osteoclasts, other monocytes, they're phagocytosis of our own material. They're responsible for phagocytosis of our own extracellular matrix. And the feature of this is regulation of calcium storage in blood. So they can in cases of when it's required, when calcium is required by our blood, so osteoclasts start to resorb a little part of bone, and calcium is released into the extracellular matrix and then into the blood, and by this calcium level in blood increases. And you remember, calcium is involved in a lot of processes, so starting from the muscle contraction, nerve signal transmission, and also in blood clotting. So calcium is one of the most important ions in the blood, so which regulatory ion of the blood. So, and that's why we need to keep the calcium level in blood, so in some on some level. And of course, we can use bones as a storage of this calcium, and osteoclasts are helping in this. But we have another function of osteoclast, which so just keep it in mind that osteoclast has one more, much more important function. Okay, extracellular matrix of the bone is known as lamella. So lamella. So you remember we discussed this lamella, and it's typical for lamellar bones only. So lamellar bones are the bones. So all our adult bones are lamellar bones. Okay, and of course we have central canal. So central canal, which is present with a lymphatic vessel, artery, vein, and nerve. So that's we discussed already. So this is osteon. Let's talk about extracellular matrix. Extracellular matrix, as I said, is half by half. It's present in organic portion and inorganic portion. So organic portion is composed of same as connective tissue, same as fibrous connective tissue. It's collagen type 1 predominantly and ground substance. But ground substance is minimal, composed of glycosaminoglycans such as chondroitin sulfate, keratan sulfate, and zinc glycoproteins. And the main feature of them is avidly bind calcium. They avidly bind calcium. That's the main idea of our organic portion. We can attach calcium to this. And you remember calcium phosphate. And inorganic portion, so an inorganic portion, it's composed of calcium and phosphate. And resorption of this inorganic portion causes the calcium releasing, and the deposition of calcium in inorganic portion causes the calcium depression. So actually, this in physiology of endocrine system you discussed, it's action of calcitonin and parathyroid hormone. Yeah. So you remember that it is regulated by these hormones. So that's the amount of inorganic portion in these areas. And in pathology, we will also discuss it again, so how inorganic portion is deposed there. So, components of bone cells, osteoblasts. Okay, we discussed as a function secrete osteoid. So, yeah, osteoid. So, this term, osteoid. Osteoid is an organic portion of lamella. So, once again, lamella is a extracellular matrix. And lamella is composed of organic portion and inorganic portion. So organic portion of lamella is known as osteoid. First function of osteoblast is same as fibroblast. It secretes extracellular matrix. But along with it, it produces the ground substance, which is avidly binds the calcium. And calcium, when can mineralize it, the osteoid with the calcium phosphate. It happens with the help of alkalic phosphatase. So please remember, alkalic phosphatase, that enzyme which captures the calcium from the blood and deposits it into the lamella. It deposits it into the osteoid. So this enzyme is present in osteoblasts, alkalic phosphatase. Alkalic phosphatase is present in osteoblasts. Osteocytes are they are present inside the extracellular matrix, and it's already enveloped. But what's the difference between cartilage, chondrocyte, and osteocyte? Actually, these osteocytes they still connected one cell to another. One osteocyte is connected to another osteocyte with the help of canaliculi. So these small connections between cells, they are known as canaliculi. So here. Not these ones. They are not. But only these lateral connections, they are canalically. It is connection like in epithelial cells, so with the gap junctions, it's necessary to exchange the material between different cells. So they are not alone, same alone as, for example, cartilages. So chondroblasts, they are alone with each other, but osteocytes are interconnected with each other. Okay, and then osteoclasts. Osteoclasts, they possess acid phosphatase. So you remember in osteoblasts we had alkalic phosphatase. Osteoclasts possess acid phosphatase, and as name implies, their function is dissimilar. It's different, and acid phosphatase resorbs the bone, resorbs the calcium phosphate, and causing as I said before, so calcium releasing in extracellular matrix, from which it shared into the blood, and that's how calcium level in blood increases. Osteoclasts are under direct control of the parathyroid hormone. An increased amount of parathyroid hormone causes the resorption of more bone, and in one hand it causes the osteoporosis, formation of porous bone, so when calcium deposition is not so well, and also it causes another hypercalcemia, which causes the formation of stones in kidneys, and also some other effects like nervous tissue effects, like hyperactivity of nervous system and muscles. So also might cause the shivering in muscles. So that's okay. It's a disease. We'll discuss it in pathology, parathyroid hormone overexpression. But the main idea is that osteoclasts in direct control of parathyroid hormone. Okay, and osteoclasts are lying in a special lacuna. So you see, if this lacuna is made, lacuna of osteocytes is made by surrounding itself and then shrinkage of the cell, right? So it's made passively made lacuna. But in osteoclasts, around the osteoclast, we have a specific type of lacuna. It is known as Howe-Ship's lacuna. Howe-Ship's lacuna. So what's the main idea? Howe-Ship's lacuna is a lacuna which is made due to resorption of bone, and you remember that osteoclast resorb bone and then stops resorbing when parathyroid hormone does not present. And due to this, around the osteoclast we have some empty space which where in cases osteoclasts are not actively resorbing the bone. So that's known as Howe-Ship's lacuna. This is depression in the bone, which form as osteoclast resorb bone. So as I said before. Yeah, one more idea. These osteoclasts are very large in size, and they are multinucleated. So usually possess a lot of nucleuses inside it, and it possess usually this outgrowths of cytoplasm, which are like pseudopods, which touching the bone, so which try to find where this cell can resorb more and more. So that's main idea. That's main idea of osteoclasts. The surface covering of the bone. A surface covering of the bone is made up of periosteum, and periosteum is composed of same two layers as we discussed in cartilages. Periosteum same as perichondrium. It possesses fibrous layer, which is composed of dense connective tissue, and osteogenic layer. Osteogenic layer, which is composed of osteoblasts and osteoclasts. That's the main difference, yeah. Osteogenic layer of bones, they are composed not only of bone forming cells but also of bone resorbing cells. That's why in osteogenic layer we have osteoblasts and osteoclasts. Fibrous layer, so function of fibrous layer is similar. Fibrous layer is similar as formation of blood vessels. So I mean not formation, I mean storage of blood vessels, and nourishment of the bone goes through the fibrous layer first of all. Also, fibrous layer is necessary for protection of bones, so from surface, and responsible for attachments of insertion of muscles or ligaments to the bone. That's one function. And actually, don't forget that these osteoblasts, chondroblasts, fibroblasts, they are cells of the same formation. They are all mesenchymal cells, and they can and one can change into another. So usually fibroblast can be changed or in osteoblast or in chondroblast. And here, that's why sometimes this fibrous layer serves as a reserved cell source for the osteogenic layer. So fibrous layer can produce osteogenic layered cells. So first of all, osteoblasts. Sorry. So this periosteum is well vascularized and richly innervated. That's why fracture of bones is so painful. So because of very abundant innervation in this area. So what about endosteum? So you remember that from inner side of bone it possesses the cavity, especially in long bones, and all the cells which are present inside the spongy bone, they're also lined up with endosteum. So what is the composition of endosteum? They compose a single row of osteoblasts, osteoclasts, and osteoprogenitor cells. Osteoprogenitor cells is a future osteoblast cell. So okay, you shouldn't remember osteoprogenitor cells, but at least remember that endosteum is composed similar to periosteum but without fibrous layer. In endosteum we have no fibrous layer, we have only osteoblasts and osteoclasts. And if you remember better, so you remember that osteoprogenitor cells, their role is similar to fibroblasts of fibrous layer. So they also serves as a source of new forming cells. So endosteum serves as a means of bone growth and or resorption. So let's discuss it. And now we switch to the toughest part of this lecture. It is a microscopic appearance of bone. Microscopic appearance of bone so gives us two main appearances. It's a lamellar mature bone. These osteons which we discussed before, yes, so they are typical for lamellar bone, and even loose. Spongy bone is also lamellar bone because they possess inside in the structure of lamellar bone we can find this osteoids. So that's lamellar bone. Okay, we'll discuss it later. But before it, in immature bodies, so when bones are just primarily formed, it is so bones are present with woven or immature bone. It's the first bone which is deposed in our body. So, and what's the principle of this? It might be spongy or compact, so it's so similar to this. But take a look on our arrangement here. Cells which are found here, they are very abundant, and they are trying to invade more and more space. Blood vessels are not arranged in a good fashion. They are arranged so chaotically. They are arranged chaotically. They are just firstly entered into this tissue. So you see, it's not organized. And I usually have this comparison of this settlement of cells of bones in woven bone with the settlement of American citizens in very beginning. Yeah, so in 15th century. So how it happened? So when every newcomer to the America so came there and proclaimed himself as a owner of their land, yeah. So one citizen came there and proclaimed, so this is my land now. This is my land, and they start to occupy this land by formation of extracellular matrix. Another cell here start to produce the another occupy another space, but between them appeared very loose land, so land which is not used. So this free space, and of course it's not well organized, and of course there will be less calcium deposition, of course there will be more ground substance, and these spaces are not well but because other cells they restricted the approach to this land, yeah, to this site of bone. So no more cells can enter into this area, and that's why this loose part of this bone so is still present in the middle, and it causes the fractures. Yeah, so this bone is very easy to be fractured, and that is typical for woven or immature bone. And blood vessels are not so well organized. So you see, they contain osteocytes that are more numerous and spherical than those of lamellar bone. These osteocytes are not in any orderly arrangement. And they're less well mineralized because of this bad arrangement. They can't facilitate the normal calcification of this bone, and that's why here this bone is very loosely arranged. But very soon this bone gets organized with the help of process of bone formation, which is also we'll discuss it today. With the help of bone formation by process of resorption and formation, this woven bone is replaced by lamellar or mature bone. So they replaces most woven bone or maybe deposit de novo. They might be either spongy or compact. Is referred to as a lamellar bone because the matrix is deposited in layers or lamella. So that's lamella we discussed before. So this lamella, okay. You understand. It's much better mineralized because it's very well arranged. So all of the responsibility is shared to each other. So it resembles modern America, yeah, modern USA. So where everything is arranged well, so everyone doing their job and don't and it is always followed with restrictions and formations. Yeah, it's formed. With help of resorption and formation. So all the old mechanisms, all the old institutions in this country, they're destroyed, and then instead of them form new ones. Yeah. So to make it stronger. Yeah. Same to this bone. lamellar and mature bones, they resorbed and renewed all the time. This bone is renewed, and due to resorption, it causes the maintain the normal structure. Okay, this is lamellar or mature bone. So now I want to pay your attention to this one. You see, it's like whole something like acid burying the bone. So actually, these cells are osteoclasts, and later I will show it to you. So how these osteoclasts are working in the bones. So architecture of the adult compact lamellar bone is possessed of outer circumferential lamella and inner circumferential lamella. So outer is outside, inner is inside, and between them we have osteoids. Between osteoids we have intermediate, so interstitial lamella. So also present interstitial lamella here. So inside the osteoid we have canals. So name of these canals we'll discuss later. Okay, so yeah, right now you see inside the osteon we have the Haversian canal, so it's known as Haversian canal. So please remember the spelling and pronunciation. Haversian canal, Haversian system. So this Haversian system, they're present inside the bone, and they are interconnected with each other. They are interconnected with each other with Volkmann's canals. Volkmann's canals. So it's not present here, but Volkmann canals are present between these osteons, which interconnect them and which facilitate the supplement by blood of all the bone. So all of them are interconnected, and this network of the blood present inside the compact part of bone. So once again, bone is not like stone. Bone is a live tissue. So usually students think about it like bone is something which already dead. Yeah, so when you don't care about it. Yeah, so that it's like stone, it's solid, but actually inside it possesses life. With a bloodstream inside, and with the living cells inside, and also there is a replacement of old cells with the new cells, the replacement of old matrix with a new matrix. So it's always in process of renewing. So it's a bone. Okay. We have so once again we have concentric lamella, external circumferential lamella, internal circumferential lamella. Also it possesses osteons with concentric lamella here, so which surrounds the Haversian canal. So this is Haversian canal, yeah, so like here, Haversian canal. And they possess a few rows, it's 4 to 12 lamella which present around this. Okay, and there are usually these osteons are present along the bone. So if you see the bone here, they are arranged in this direction, up and down. They are not present in this way, in lateral way. They are not present. They are present only in up and down fashion. So here, and just imagine that we have strands of bones which are present here, and deposition of lamella is going in a very interesting fashion. It goes in orientation, so right and up in clock, opposite to clockwise, then along the clockwise, opposite to clockwise, and along with clockwise, and every lamella is overlapping another lamella, which makes a very extremely tough structure, which doesn't allow the fractures. That's why fractures are not so common. So fractures are common only after the over stress. That's why bones are. So you heard about it. So bones are by architecture they are a little more solid than metals. So that some metals. So that's why it's happened because of this arrangement of fibers and deposition of this deposition this spiral arrangement of the lamella. So it goes in this structure. It goes in this hard structure of this. But take a look. Yeah, once again, osteocytes are present in their lacuna, and between this, between these cells are connected by canaliculi, yeah, and we have network of cells there. So here we have the canal, Haversian canal, and between them we have the Volkmann's canal or Folkmann's canal. So it's a German scientist, Folkmann, and that's why it's better to pronounce it like Folkmann's canal. So it's due to respect to Folkmann. But you can pronounce it like Volkmann canal, so it doesn't matter. Okay, and from the and you see blood goes into the bone with from periosteum, and then enters inside, and then blood distributes all over the all over the bone, and even enter into the bone marrow. So, and here in cancellous bones we have bone marrow, and here we have the recruitment of new leukocytes and erythrocytes and other cells of blood and thrombocytes too. So here we have interstitial lamella, Volkmann's canal, and yeah, don't forget about cement lines. Cement lines, they're present around the Haversian system. They are like, it's a point which you cannot understand right now. So you need to understand next point. So bone growth and deposition, then I'll return back to the cement lines. So bone growth and deposition and resorption. So bone growth starts from the cartilage, hyaline cartilage. This is a fetal skeleton, right? And fetal skeleton is on the fetal skeleton appeared cells on the surface, which cells we'll discuss later. But they are osteocytes. Okay, let's name them osteocytes and osteoclasts. They appeared on the surface of these cartilages. And this is a primary ossification center. It is a primary ossification center, and you see these cells are responsible for activation of blood entering to this area. So they have a special opportunity to invite the blood vessels. So actually, they produce vascular endothelial growth factor and notch ligands, notch factors, which causes the formation of more blood vessels inside. It's we will discuss it in pathology actually, but main idea is that these cells they invite the blood vessels to this area. And here, and the first thing these bone cells are present. Bone cells do with the cartilage. They start to calcify this cartilage. So you see this purple color is a calcified cartilage. This calcified cartilage happens, and inside the calcified cartilage, these cells, like osteoclasts, are entered inside, resorb the previously formed calcified cartilage, and it leads to entering the blood vessels inside. And blood vessels, along with the osteoclasts and osteoblasts, they entered inside, resorb the previously formed cartilage, and instead of previously formed cartilage, forming the bone. And here you see this. Yeah, so along with the blood vessels entered, so bone formation happens. Bone formation continues. And here happens the secondary ossification center, so it's by the same fashion as it was present here. By the same fashion it happens. But anyway, and in some time, so the secondary ossification center meets the primary ossification center. Yeah, and between them appeared this structure, and you already remember it's epiphyseal plate. Epiphyseal plate. This epiphyseal plate, which is responsible for further growth of bone in lengths. And so that's why in children it still remains. So, and that's why in children we have number 9 bone structure. So we have only proximal epiphyseal plate, and growth is happened there. And you see this that cartilage which is present in joints. It is also made of the same cartilage which was in fetal period. fetal period. So it's we used to think that this cartilage on the surface of bone is appeared somewhere later after the bone. It's usually it's a mind exercise. So you when you think about it, so it looks like it later. So first of all, we have bone, and then cartilage is attached to this. But actually, it's wrong. Actually, it goes in opposite way. So first of all, we have cartilage, and then bone just replaced all the cartilage beside this part, these peripheral parts of the bone. Okay, and this is this formation. Okay, how bone growth, deposition, and resorption happens. So take a look. Actually, we have a lot of zones here. So now I see that you are already, so when you see these names, you are already start to sleep and start to afraid of these names. Yeah, so but let's talk about them. So it's not so tough as you think about it. So first of all, we have zone of resort cartilage. Zone of resort cartilage in epiphyseal plate. So when we have epiphyseal plate, so you remember it is present with cartilage, and this cartilage is able for interstitial growth. You remember we have appositional growth and interstitial growth of cartilage. Yeah, interstitial growth when growth happens inside the cell, and this reserved cartilage is able for growth, and they start to grow. So interstitially, because blood vessels are very abundant here, so that's why it's easily can grow. But then, when it gets closer to then cells which get closer to the source of blood, and bones are a source of blood. You remember that bone structure, bone which is formed before. So it's a source of blood because inside the Haversian canals we have blood vessels. And when it gets closer to blood, so it gets more nourished, and they start to proliferate. They start the division process, zone of proliferation. So these cells start to proliferate and form a lot of cells. And proliferation, so somehow by mechanism which is programmed by these cells, this proliferation later causes the hypertrophy. And along with the hypertrophy, they start to attach calcium. They start to attach calcium, and it forms the next zone, which is known as zone of calcified cartilage. So calcium is deposed in these areas, and this is calcified cartilage now. Okay, and then you remember that calcified cartilage is formed here, and calcium is very good. So calcium extracellular matrix with the calcium, it's a very good source for osteoclasts. And osteoclast will drill this calcified cartilage, and this side of drilling it is known as zone of resorption. So this side, when calcified cartilage is resorbed by osteoclasts of forming bone, it is known as zone of resorption. And of course, but after the resorption, so this part which already constitute a new bone, so where osteoblasts are already formed and they produce extracellular matrix, it is known as it's a bone. Actually, everything which is here, it is a bone. Yeah, everything which is here, it is a cartilage. So I want to write it. Okay. That's what is visible. Once again, zone of reserved cartilage, but cartilage is reserved in their position, so without cell division. Then, due to presence of nutritional factors and oxygen, so it starts to undergo the proliferation. And cells they just divided mitotically. Then mitotic division is stopped, and then starts the zone of hypertrophy. So when cells are enlarged in size. And these enlarged inside cells start to depose calcium around them and forms a zone of calcified cartilage. And then a zone of calcified cartilage is easily resorbed by osteoclasts. And these osteoclasts, they invade the site and forming the new bone. But you see, it might be counterintuitive for you. So usually we used to think that cartilage, when it's calcified, it's named as bone. But it is wrong. Actually, bone is not calcified cartilage. Bone is made instead of calcified cartilage, and it's active process. It's not passive accumulation of calcium. We need to resorb the calcified cartilage, and then instead of calcified cartilage, forming the new bone. So bone resorption, so it's okay. Let's show the bone resorption. So you remember the diagram I shared you before. So remember the diagram one. So this diagram, yeah, I shown you this green cells, yeah, and I said they're osteoclasts which resorb in the previous bone. So and lamellar bone is based on the principle that we need to resorb previously formed bone and instead of it produce new bone. So let's turn back to this. And this it was these green cells. They're osteoclasts, and they resorb previously formed bone. So previous lamellar bone doesn't matter. It might be calcified cartilage created in the same fashion. So they resorb previously formed calcified cartilage. It also resorbs the previously formed the woven bone. It also resorbs the previously formed lamellar bone. Doesn't matter. So every calcified material might be resorbed by osteoclasts. And this osteoclast, they create the cutting cone. This cutting cone, it's resorbing cone. So this it goes along with the bone. Yeah. So you see, it renewing goes along with the bone. It resorbs the bone on the way and forming the gaps. Yeah. So just forming the canal. But what goes after the osteoclasts? After the osteoclasts, we have osteoblasts. And you remember the function of osteoblasts. They start to produce extracellular matrix. And extracellular matrix, along with production of extracellular matrix, so this cone, cutting cone, starts to get narrower. And this part is known as a closing cone. So, sorry. It's known as a closing cone. So when osteoblasts are reconstitute, reforming this bone, so which was destroyed by osteoclasts, and then only after this, so small canal which is remained here, it is Haversian canal. And you see, of course, osteoclasts require blood. Then osteoblasts require blood. That's why here it's not shown, but here we have, of course, we have blood vessel. Here, along with the along with the resorption of bone, along with the formation of new osteon, we have resorption of bone along with it. That's the main idea of this growth. And okay, and why do we need to resorb previously normal bone? Yeah, we should think that normal bone. So why we need to remove it? So it's solid. But here I make I want you to make a mental experiment. So just imagine you have a stone in your hands and you have a little hammer in another hand. Yeah, and a very little hammer. And if you punch it once, so will stone be destroyed? Probably not. Yeah. So actually, if you punch it once, so it will stored. Yeah. But if you start to punch it, so 1 minute. If you start to punch it once a second for I don't know, for 10 years, yeah, for 10 years. So what would remain after 10 years? So only dust will be there. Yeah. So instead of this bone, instead of the stone, will be just dust. So it's a property of inorganic compounds. So they collect the damage. So a very small damage to the bone, to the stone, is not visible. It's not dangerous for us. But collection of more and more of this the injuries causing the disruption of entire bone, entire stone or bone, doesn't matter. Inorganic material, any mineral possesses this property, and that's why we need to recomposite it. So even if it looks like not damaged, we are walking, we just collide with something else. Yeah, we just collide with the walls. We interact with the external environment. And of course, this bone collecting some little fractures inside, and to restore them, to reforming of them. So we need to produce new osteons. We need to produce new osteoclasts, so new forming the new lamella by new osteoblasts. Okay, that's the main idea. And that's why. And now you can understand the fashion of the fashion of osteoid. Yeah, why osteoid is round in size? Because it round in resorption, and then it round in formation. Yeah, so it's round in formation, so it's less and less and less, and every time I write it, so it's we have one more lamella, and that's why it has concentric lamella in this way. So this is the first lamella, this is second, so 1 2 3, then 5, until 20 times it might be present, so it depends on type of bone and activity of resorption. And you remember I said to you we have cement lines. Cement lines is a this part. So this part, I hope you see I'm drawing. This cement lines, or this is a line which is made by osteoclast resorption. You remember that osteoclast possess the Howship's lacuna. Yeah, Howship's lacuna. And this Howship's lacuna, and the remnant of this Howship's lacuna, it's looked like cement lines. So it's like border where a previous bone, previous osteon has drilled the previous bone. And you see, this is concentric lamella, this is concentric lamella. But what is this between them? Between them is interstitial lamella. But interstitial lamella, sometimes before it was another osteon. But due to resorption of by new osteon, so this intermediate part of this just remained. So for example, here it will be resorbed. So once again, I'll try to draw it. So just imagine that now this cone will resorb it here. So and here will be new osteon. So what happens to this part? So it was another osteon here, but this part will be remained, and this part will become the interstitial lamella. So that's a principle of bone renewing, and that's why we have so interesting arrangement of the bone, because of resorption of this bone with help of osteoclasts. Please capture this. It was must tough explanation, a must tough point of discussion. If you remember this, it is best for you. So, but I'm pretty sure that you require reading of this again, and also watching this lecture again and again to understand it. Now let's talk about bone development. We have two types of bone development. Two types of ossification. So bone development is also known as ossification. Bones are usually formed instead of other tissues. And there are two types of tissues which are going. So first of all, it's a mesenchymal membrane and cartilages. A mesenchymal membrane is ossified with the help of intramembranous ossification. So this intramembranous ossification, it happens when osteoclasts and osteoblasts are appeared on the membrane of mesenchymal cells. And this fashion is typical for flattened bones of our, for example, of the brain. Of the brain case of our skull. So flattened bones of our skull are ossified in this fashion. So when osteoblasts they are appeared here, and they start to form ossification center, and from this ossification center it starts to spread outside, and some cells remained in the middle and forming the osteocytes, but osteoblasts are appeared peripherally, and by this in this fashion, so it just like occupies the entire membrane. And also, of course, you remember I said that osteoblasts, they have opportunity to invite blood vessels inside this. And here, first of all, forms a woven bone. You see its typical appearance of woven bone, and later, so after the time of resorption and formation, also reformation, it causes the formation of the from woven bone. It causes the formation of lamellar bone as it used to be. And another one is endochondral ossification. So endochondral ossification we already discussed. It starts with the same idea. So on the surface of cartilage we have mesenchymal cells, and here also starts in the same way. Some osteoblasts are appeared on the surface. But we require calcification of this cartilage and then entrance of blood vessels inside this bone, and then resorption of calcified cartilage and formation of bone instead of it, and then finally we come to our bone. So don't forget about epiphyseal plate. So also known as epiphyseal growth plate. So it is as shown here. That's a function. Okay, that's enough. So here we have overview. So it's from another book. I just copy pasted it from another book. So it's like conclusion. It's much easier to remember. So it's easier to understand than it's much easier to understand than than my first explanation. So that's why my request to you. So you can observe this lecture again, and also you can read the book and in lecture. So a lot of information there. It's very tough. I sure that you're a little overloaded now, but still you have to remember this idea. So because you have questions in module, in classes about this topic. Okay, also group number 11. So we have class after 20 minutes. So get ready. So let me check your attendance. Don't leave yet. Okay, so let's check a chat. Let's check a chat. Okay. Okay, thank you. You can leave. Thank you for attention. See you next time.
Okay, sir. Good. Thanks.
Goodbye.